Hello everyone, in this lesson we're going to talk about Kirchhoff's rules. You're going to learn the two rules that will make your life much easier when solving circuits. Alright, so Kirchhoff's rules are actually all about conservation of charge and energy. And it was developed by Gustav Kirchhoff when he was trying to solve more complex circuits where we cannot use just simply series and parallel resistors here. So in a circuit like this, you have to find another way to solve it. So, alright, so Kirchhoff's first rule is actually called the junction rule, alright? And it states that the sum of all currents entering a junction must equal the sum of all currents leaving a junction, okay? So we have two junctions here. Everything that enters this junction must be equal everything that leaves this junction, okay? And well, Kirchhoff's second rule is the loop rule, and this rule states that the algebraic sum of changes in potential around any closed circuit's path or a loop must be zero. Let's further explore each of these rules. Okay, so let's start with the junction rule. It's pretty simple, okay? Let's imagine this junction here in a circuit. We have a current that's coming in, and it's being divided by two other currents, I2 and I3. If we apply the conservation of charge here, we can say that I1 is actually I2 plus I3, right? Let's do a practical example. So let's assume I2 equals 5 amperes, I3 equals 6 amperes. Well, by the conservation of charge, I1 is actually 5 plus 6, which gives us 11 amperes. Alright, everything that's entering must be equal everything that's leaving. Alright, now let's take a look here into the loop rule. Well, let's consider this circuit here. Alright, we have maybe a battery here and internal resistance, okay? And two other resistance here, R1 and R2. So if we apply the conservation of energy here, we have that the EMF, the electromagnetic force here, minus the current times the small resistance, minus the current times the R1, minus I times R2 is actually 0, alright? That's another way you can express the same thing I've just said, okay? So basically, every loss in potential here, and by the end of the loop must be 0. So let's do this practical example here. Let's assume these values for R and current of 2 amperes, okay? And let's try to find the EMF. So we can apply Ohm's law for each one of this resistance and find that EMF is actually the sum of all these losses in potential, alright? For this case here we have 18 volts, alright? So as I told you, each resistance gives us a loss in potential, okay? From 18 to 17, then 17 to 5, 5 to 0. So at the end of the loop here, this value must be 0. Well, you probably may ask yourself, so for the junction rule, for example, we have to assume the direction of the current here. And that's exactly what you have to do. But you don't need to worry too much about the direction, okay, of the current that's entering or leaving the junction, because in the end, if you find the correct value, right, you may find a negative value. So what it means is actually, for example, let's suppose that you assume this direction here to solve your circuit, okay? And applying Kirchhoff's first rule, the junction rule, you found that this current here and this one here are negative. So what it means actually is that the values are correct, but the directions are wrong. So you just need to change the direction here. And the same thing applies for the second rule, the loop rule. We have to assume a certain direction when solving the loop, okay? And by the end of the day, if you find negative values, it means you got the wrong direction. So you just need to invert it, okay? Stay tuned in our channel, because in the next video I'm going to solve a circuit using Kirchhoff's rule. I'm going to solve it step by step, so stay tuned and check out our next video.
Now that you've learned the theory, it's time to put that to practice. Check out our next videos for practical problems.